All right, so for this question, we can approach this either using tables or the calculator. I think they're both equally as fast to complete this question. So one of the main things we need to understand is that most of our technology, and our tables especially, are designed to calculate this white area, all right? Area left of a z-score is the standard way. All right, so we can find that white area, and then from that we can find the blue area by deduction. And it's important to understand the way we know that is because the area under all area under the curve is 1. It's equal to the number 1. That's the entire area under the curve. So, if this is a distribution of people on their heights, 100% of the people have some height, right? You have some height, so you fit somewhere on this curve. So everybody's under here. That's why it's 100% or 1. So if we know the area here, the white area, we take 1 minus the white area will give us the blue area. Okay. So let me get the tables up. I'll show you the tables first. All right, so I apologize if I know the numbers are small here, but they actually need to be so I can fit the whole table on the screen. But if you look at the top of the table, it says the standard normal or z distribution cumulative area from the left. Right, it can tell us the area from the left, starting at the far left and going all the way up to our z-score. So all the area left of some z-score. And so that's what I was trying to describe here. The tables will only tell us the white area. We want to know the blue. All right, so the way we find this white area is we go look for the first decimal in this column. All right, so go down to negative 0.8. It's right here. All right, negative 0.8. It's right there. And then the second decimal, 2, we come across to, this is 0.80, negative 0.81, negative 0.82. There's a small 2 there. It's hard to see. And we go down and we find where those two intersect. And they intersect right there at the number 0.2061. So this white area is 0.2061. So if we use what I stated earlier, we'll take 1 minus that white area, 0.2061. That will equal the blue area, and that's 0.7939 if you check that with a calculator. All right, so that's the way we do that with a table. Now let me show you with the graphing calculator. So with the graphing calculator, what we do here is we'll go to second, press the yellow second button and come over and press vars. If you notice right above vars is DISTR for distribution. We're looking at a normal distribution here. And so we're going to use normal, and when we do normal, we always do normal CDF. That's one thing it's important to know. Normal PDF almost was just basically never used. All right, so normal CDF is going to tell us the area under this curve. Now here with the graphing calculator, we need to tell it where do we start and where do we end. All right, so we're going to go from, we start here, the furthest left point to describe the blue area is negative 0.82. Negative 0.82. Make sure you use the negative button, not the minus. The calculator doesn't like minus, it wants the negative. All right, and then comma. And now this blue area extends all the way out here, in fact, to infinity, really. It's hard to see. It's what we call an asymptote, right? It means it's something that goes on forever, but never actually touches it. So we're going to go up to positive infinity, and I'll just represent positive infinity with 9999. All right, that's a gigantic positive number. And when we do that, we get the same answer, 0.79389, which rounds up to 0.7939, which we got earlier. And just to show you how this works then with the, if we did it the other way, if we tried to find the white area, here's how you find the white area, just to show you that it does actually hold water. Negative 999, comma, so we're going to go from negative infinity, that's the far left end here, and we're going to go up to negative 0.82. And I left off my negative 0.82. And what we'll find when we go from the left all the way up to negative 0.82, we get what we call the complement here. We get the 0.2061. And if you take these two numbers right here and add them together, they'll equal 1, which just kind of further substantiates this fact that the area under the curve has to be 1. All right, so hopefully that helps describe this whole process.